introduce you to the audience, sir.
Yes.
So, good morning, participants. We have with us Dr. Harshit K. Dave from SVNIT Surat. Lovely Engineering College is the alma mater for him, and he is a very good and noble teacher. I will not say anything more, but I am requesting Professor Amit, who is my colleague, to introduce Harshit K. Dave to the participants. Amit, sir.
Thank you, madam. Very good morning to one and all present in this session, and good morning to Dave sir. Dave sir uh, Dr. Dave sir is currently serving the Department of Mechanical Engineering in SVNIT Surat. He did his master degree from MS University of Vadodara and PhD from SVNIT Surat. Dr. Dave has more than 17 years of teaching and research experience. His area of interest is additive manufacturing, advanced machining, micro manufacturing, composites, fabrication and characterization. Dr. Dave has successfully completed funded research project of approx about 69 lakhs from various agencies like MHRD, MPIU, Ministry of Textiles, DST, Guj and etc. Dr. Dave has filed 4 patents, 1 patent is published and 1 patent is granted to his credit. Dr. Dave has 42 research papers published in international journals, 56 papers in international conferences, 7 papers in national journals, 11 papers in national conferences to his credit. Dr. Dave have published 2 books, Advance in Manufacturing Process in Notes in Mechanical Engineering, Springer, and the second one is Fuse Deposition Modeling based 3D printing in Springer Nature. Dr. Dave have published 3 books chapters in various Springer journals. With this brief introduction, I would request Professor Dr. Dave sir to take over this session. Thank you, sir.
Thank you, Dr. Maya and Dr. Amit for inviting me to join my own institute today, and also thanks for a nice introduction, which often I feel that it is beyond what I deserve to have. But yes, I humbly accept that I like to be called as a teacher, and I would love to remain a teacher, and that is what we all are. Everything else are temporary. They come and they go. But the rest, throughout the life, we all would cherish remaining teachers. Someday, if somebody remembers me, it would be only because of me as a teacher, not because of my publications or maybe because of my projects or so. So even in the virtual mode, it is like homecoming, because Morbi is my hometown and Eli College is my mother. So it's good to be with you virtually today, and I sincerely thank the coordinators, the entire team, as well as the institute for considering me for this program today. Thank you, and now I would like to start my presentation.
Yes.
I hope this is visible in
Yes,
full
Yes,
screen
sir.
mode. Yeah.
Yes, sir.
Yeah, I would request all to keep your mics in mute so that I don't hear those buzzing sounds. Though music is something which I like, but then often the buzz that we hear does not match well with the frequency of the way we speak. I hope my voice is clear.
yes, sir.
Fine. Okay. So good morning, friends. I welcome you to the first session today morning, wherein I would like to talk to you about actually the role of 3D printing in Industry 4.0. So I would rather talk about why 3D printing is important in Industry 4.0. So I'll begin with some discussion about 3D printing and how it matches into Industry 4.0. Eventually, that would be the last point of my discussion today. I would take you to this interesting topic. I don't know whether my talk would be interesting or not, but the topic is definitely interesting. So I hope some of you would definitely gain something out of it. And I'll take around 75 minutes for the discussion. Okay. These are few things which I wish to discuss today. First thing first, why 3D printing comes in, it is something new. But when we talk about manufacturing as a process, we have several different ways in which we can make things. The subtractive manufacturing is one of the methods where we remove excess amount of material. Rather than showing you something on lathe, I think this is an interesting example where the rock is cut, material is subtracted from it, and a artistic image emerges out of it. The other way of doing making things is by using forming methods. Now, if we go through forming methods, there are different ways of doing it, but I wish to project this particular example where a vacuum forming process is used to make an interesting toy for the kids. Beyond that, there is another method which we widely use is casting process. In casting, what you do is you have a liquid material that is poured into a mold and certain shape is obtained when it solidifies. A very good example is the chocolate that we try to make at home. So that also is an analogy with the casting process. But apart from these three, now additive manufacturing or 3D printing in simple words is another process which is coming to the prominence since last 10 to 15 years. And you would be surprised, and maybe you would know that it is capable of replacing all these three processes. You can create idols with the help of 3D printing. You can make toys the way we made through forming, and you can also print chocolates. So now these things can be applicable to almost all the fields of our engineering applications too. So 3D printing that way is a very recent process as compared to what the other processes we have been using. And as per the ASTM, 3D printing is a process wherein fabrication of objects is taking place either through the deposition of some material, wherein you use a print head or a nozzle or any other printing technology. So there are 8 specific methods of 3D printing. I'll not go into it right now, but there are 8 ways in which 3D printing can be carried out. When you compare 3D printing with the subtractive processes like say machining process, what you observe is that in specifically if you want to create a square 3D object, then your raw material has to have a specific similar shape. Say for example, if you want to carry out something on turning and you want to make a shaft, then you necessarily need a cylindrical job. Or if you want to cut an object which is visible in this image, that 3D object, then you need a square raw material. But apart from that, in case of 3D printing, your raw material can be powder, it can be some resin, or it can be a filament. You have nothing to do with the basic shape of the raw material. Process takes place and you get eventually the type of shape, any shape that you wish to have. And the other important thing is the amount of wastage that you observe as compared to specifically the subtractive process is quite less. So these are the 2 benefits. One benefit is related to the raw material, wherein you do not need to have a specific shape of raw material as desired based on the type of object that you want to have. And the other advantage is the wastage is substantially reduced with the help of this process. Another advantage which you see, especially when you compare it with the machining processes, is about the complexity of feature that you have. Generally, when you when you see subtractive manufacturing, or in that way any of the conventional manufacturing processes, as the complexity increases, we observe that the cost will also rise. So if you want to make a simple shaft, it is easier. But if you want to create steps on it, taper on it, curve on it, then you cannot use probably the conventional machine. You need to go for CNC machine. Cost of machining increases, labor cost, everything goes on increasing. So as the complexity increases, you increase the cost. Whereas in case of additive manufacturing, initially the cost is high. If you compare the cost, the initial cost is high. But whatever be the cost, it has nothing to do with complexity. Whatever be the complexity, the cost remains same, and a break even comes relatively faster. So usually the standard way of product designing, if you see, in the standard design phase only, you find that the 3D printing provides you a good break even with the cost associated with the complexity. Now, when you go beyond certain level where you try to increase the complexity, which even regular conventional processes are unable to achieve. Okay, so in such a scenario, even you increase the complexity, that becomes free. You don't need to invest anything else for that complexity. So at the same cost, you get better margin and you get higher profits. So that way, 3D printing is approaching and covering the market far more faster than what the conventional processes did in the previous century. Now, where do we use 3D printing? We use it for 4 specific tasks, which I feel. The first one being for conceptual prototypes. So prototyping, very easy. You can see these are the prototypes created by my own students. You can print anything which you can utilize to demonstrate. It is meant for demonstration. It does not help you to, it does not give you the functional applications. The other is rapid tooling, where the printed parts act as tools. Say, for example, you print patterns for casting. So these are different examples of different patterns that have been printed by one of the startups from our institute, and that is being. You can see that this is working remarkably well. So instead of creating the regular patterns by say for investment casting, you can use the patterns made from wax material that can be printed and that can be eventually used. You can see the parts, this being the pattern and this being the part. So you can see here also these are different applications where you are getting good quality products with the patterns which are made by 3D printing. Another example is, which is slowly gearing up, is printing of functional parts, the real parts that you use in the application. So you can see those AC vents for the automobile vehicles, or the coverings for different parts, or you can see this is one of the most coveted example in recent times in US, wherein a wing of the windmill is also printed. It is printed into parts. People have stood there, so you can just visualize the size. But these are the different parts which are under which it has been printed, and they have been connected very well, and that has reduced the weight, and that is how it is improving the overall efficiency of the activity, the process that is being carried out. And the most important thing is the mass customization. Customization was the initial phase, say 500, 400 years back, 300 years back, where a specific part was made as per the requirement. But later on, during industrial revolution, the first and the second revolution, when mass production took lead, it became a faster and it became a cheaper way, and hence we stopped making custom parts required as per the need of an individual. But if we take the customization with help of 3D printing, it is possible to print customized parts even at lesser cost and faster than mass production. So you can have a shoe made for yourself. You can have a artificial limb printed for yourself. And if in case if that is to be used by say kids grow fast. So within few months their size would change. The same drawing, the same design, you can just scale up depending on the scale of growth, and you can print a new part. So mass customization has become a, though it may not be the requirement for individual centric, but for industrial purpose. If there is a part which breaks, you don't need to buy n number of parts or ask someone to fabricate. You can have your own printer, and whatever part breaks, you can immediately print, and you can fit in as we saw in one of the previous slides. So mass customization, be it at individual level or be it at industrial level, through 3D printing, it is taking place. 3D printing also has a very significant role in the supply chain. The time that is being taken, the expenses that are being incurred. If you see the 3D printing, it is somehow helping to reduce the transportation. Say you can, in usual case, what happens is an idea is converted into prototype, and if it works well, once it is finalized, you go for production, you assemble the parts. Then it, after packaging, it goes to distribution network, then it goes to warehouses, and then it goes to dealers, and then to retailers, and you go to the retailer and buy it. So the customer gets a part after initiation of the process, 3 to 6 months of time. So today, if we get a new brand of mobile, probably they have started using, working on it 6 months or 12 months back. Even today, the total time elapsed in a new product development is drastically reduced. But still, you don't make a mobile at your place. You don't make a toy at your place. You don't make certain medicines at your place. Everything that happens, say you do not make the parts that are required to operate for orthopedic operations, you don't make at your place. They are made at certain place and they are transported to you. But eventually, this supply chain can be drastically reduced if 3D printing is brought into picture. Whatever idea you have, you can create a prototype, and then immediately you can go into its production by as a functional part. And who can do it? The customer can also do it. So somebody who is involved into say food industry, he can have a 3D printer for food. If somebody is involved into surgical instruments or surgical parts, you can print those titanium parts at your place, and immediately the doctors can have it. So in no time you can work on, you can scan the broken limbs of a patient, and immediately you can print. So the time that is elapsed can be drastically reduced. However, it will have its own cost associated with it. But where does it work well? This is an example where it works well. This is the International Space Station, which revolves around the Earth 24/7. Amazon does not deliver to them. So if they need something, they have to wait for say 12 months of time when the next space shuttle comes, and they have to wait till then. But for many of their problems, they use a 3D printer, a specific customized 3D printer for them, and they print the parts for them. Made in Space is a web page on the website of NASA. You can go through it. They have many more such examples. So the customization is happening at your own doorsteps. You don't need the entire supply chain to take care of your requirements. Over and above this, it works well in disaster management also. 4 or 5 years back, there was a very, very severe earthquake in Nepal. And because it is a hilly terrain, the supply of water was an issue, because you had those roads blocked because of the stones, huge stones falling, rocks falling apart, and the supply of water was also a problem because the pipeline had broken at different places. But then through UNICEF, around 500 small 3D printers were brought in. About 1,000 people came, and in a group of two, they worked at different local places. As per the requirement, they printed the parts and joined and fixed the problems. And within 2 days, water supply was resumed. India was also involved into that service at that point of time. So you don't need to bring the entire industry. You can just carry a small machine in a suitcase and bring it into working condition and do your task. So this is how probably it works in such cases also. Over and above this, 3D printing is helping us to connect the virtual life to physical life. Why I am saying this is, you must have noticed that many of us are the college students to the larger extent, and our school going kids to a very larger extent. They are totally dependent on mobiles today. And because of COVID, now everything being, all studies being online, they have mobiles 24 by 7 in their hands. So when there are no class or even during class, they mute the class, and they may often get carried away by cartoons or maybe by some serials, or maybe students, college students may be into some other recreational activities. So it becomes very difficult to concentrate on the studies, number one. It is now taking time because it has become a very habitual thing. So kids, even I see at my place, at my home, my own son, he often gets busy with some sort of cartoons or serials, and he does not want to go out for play. So the thing is, our social life, our circles are getting reduced because of this, and that is bound to happen. We cannot avoid it or eliminate it. We can try to control it. But in recent times, some experimentation was done somewhere in Greece. One of my friend over there in a university, he shared this information that what they are doing is, now they are focusing that the kids should work on their mobile. They should do some designs on the mobile. So with the help of cloud computing, servers are provided through the mobile, and the softwares can be accessed on the mobile, and you can create some 3D drawings using your mobile. And the same drawings you can connect through Wi-Fi with the 3D printers, and you can print them. So in a way, again, kids came back to the laboratories because their primary source of interest was the mobile. They had it in their hands. So rather than avoiding it, 3D printer is now becoming a supplementary thing with it, and it is extending the interest in the studies and hobbies and games and whatnot. So that is how probably it is helping for the kids to come out from mere mobile activities. So this is what a 3D printing process has been able to do in some cases, and maybe we can try at our own small circles and see if it helps. Many of the schools today have started using 3D printing, so kids are taking good interest into it. I myself see that students from civil or from chemical or say electronics background, they come to my lab for printing very small parts, and that's how the mechanical guys get involved with the other guys, and eventually everybody learns and grows together. So this has become an interesting tool. There were days when kids used to come and may ask in the workshop to do some welding. They'll put up the things and go away. After 2 days, they would collect anything related to welding or some machining or bending, whatever they needed. They were not that interested in doing it. But because now you are using software, because now you are using cloud-based mobile operated software and 3D printers, students are taking interest into it, and that is how there are a positive shift happening into the activities. The same connection between virtual and physical happens in Industry 4.0. How does that happen? So we, in a way, when we are doing it at local level, using 3D printing for our kids, the same thing happens at a global level, wherein physical systems are getting connected virtually. So it's not that different parts of a factory are getting connected. Different factories at different locations are also getting connected. So what you need is the requirement of some sort of automation in your activity. You need good robotic based motion control into it. You need the intelligent source of data transfer into it, and all of them connected through some sort of servers, wherein in real time you can pass on the information. So you can work on small projects at a small place. You can see this over here. People also work along with these robots, which can pass on the things from one place to other. So it's like an advanced version of FMS, and you can see that even large industrial setups can also benefit through this. So products also pass at a different pace at different locations, and the information also passes parallelly. And this is clubbed together in such a way that a cyber physical system is evolved. So the thing is, you are free now. You do not control these automated systems just as you control a flexible manufacturing system setup, or you do not control a robot just as we are used to do at an individual level. You do not operate the machine at an individual level. Everything that happens either through the automated systems which you operate, or altogether they are AI enabled so that they think by themselves and they work by themselves. You only are required to make certain, to feed certain requirements, to feed certain rules, to feed certain criteria, and rest of the things are very well taken care of by the system. So that is what Industry 4.0 is meant for. I'm sure that this must have been discussed by many of the speakers before me in the last 3 days of time. But still, I feel that this would be a good, I would try to establish this connectivity with 3D printing in some of the other way. Now, when we see different industrial revolutions, the first revolution that you had was about 200 years back, and since then we have seen 3 successful industrial revolutions. People say that right now is the era of Industry 4.0, but I believe that Industry 3.0 is still going on, and it is evolving into a Industry 4.0. So current age, this decade, or maybe coming decade, may not be fully Industry 4.0, but it would be some sort of combination of 3.0 and 4.0. If we see through the historical background, the first industrial revolution started in Europe sometime in the 18th century, where large-scale automation of the process was carried out. So instead of you being involved into each and every phase of the production of a part, you used mechanical power instead of the human power to carry out the task. It led to better efficiency and it led to faster outputs. Then in the Industry 2.0, which began somewhere in the at the intersection of 19th and 20th century, first there was the mass production at the level of automobiles in US, and that came to picture through the assembly line that was devised for textile industry in Japan, followed by the Toyota company, and then from there it went to US, and then rest is the history. So we reached a stage where mass production was taking place, number one, and interchangeability became a rule. So rather than going for customization of a part, you produce interchangeable parts on a very large scale. That led to faster production, larger quantity of production, and it helped in a way during the Great Recession that came after the First World War. So this mass production in a way helped to reduce the cost and hence take care of the pocket of the people as well as the profit of the manufacturers. So that's why this became a buzzword, Industry 2.0. In Industry 3.0, now we are reducing the involvement of men. Instead of that, you have computers and you have automated the system. So the machines work by themselves, they are controlled through computers. But to operate this computer and to set up the machines, you still need the involvement of the humans. So automation has gone far and wide, and the starting from the first IBM computer that might have been size of a regular office size, it has drastically reduced to laptop size, and its capability increased, and so automation has also increased. But in this case also, a human intervention is constantly required. But when you go through Industry 4.0, more or less the systems remain same. Physical systems, it's not that you throw away your machines, you throw away your factories. But what you do is you automate them with the help of self-learning systems. So the thing is here, what you do is you have a huge capability of computer systems where it has many algorithms which can take decisions based on either the previous experience or the data set or the rules that you have given. So it takes its own decisions, and you are only required to feed or connect them together. So that way, Industry 3 and Industry 4, we are somewhere in between. As far as in India is concerned, 4.0 is slowly taking up, but still, far and wide industries are still into Industry 3.0 mode as far as India is concerned. So what is Industry 4.0? I hope this must already have been discussed. So here you have three technological trends which are helping to transform Industry 3.0 into Industry 4.0. And these are connectivity, intelligence, and flexible automation. So what you do is the automation that you had, you are trying to make it more flexible. So something which can be done on one machine can be done on many machines at a time, or maybe in parallel simultaneously. And you connect those systems together. Not only you connect them, you use a program, an algorithm in its operation, which is intelligent enough to take decisions. So just as we have simple decisions of 0 and 1, on and off through PLC systems, now you have algorithms which utilize the previous decision, all previous decisions, or the data set that are fed to it, and it tries to judge the situation the way a human judges, and it takes the decisions, say for example, setting of parameters, say for example, setting of speed, say for example, taking care of temperature, say for example, taking care of pressure, say for example, transmitting information, say for example, transmitting the product so that in the handling system, they do not collide with each other, and they do not have unnecessarily waiting time. So those scheduling and those activities which are peripheral activities with the production, they are also very well taken care of with the help of such a system. So in a way, what you do is you converge two separate entities today. Information technology is a very strong entity, as well as operational technologies, manufacturing technology, operational management. These are also very evident and strong technologies in Industry 3.0. But these two are separate entities as a whole. And what you try to do is you try to converge both of them together. You try to bring both of them together. You try to merge certain aspects of both of them together and create a system which is a cyber physical environment, a cyber physical system, a cyber physical setup. And that setup is Industry 4.0. So this convergence which you see between IT and operational technology, that becomes possible because various digital solutions have come up, various advanced technologies have emerged, and those technologies, those combinations, they are working simultaneously, hand to hand together. So this leads to certain technological pillars of Industry 4.0. So if you can see that there are different aspects, different technological pillars which are based on advanced technologies and certain digital solutions. Chief among them being Internet of Things, big data, as well as its analysis, the cloud computing. This works through mobile technologies. The internet technology, IoT works well with RFID marking and certain decisions made artificially through cognitive computing. And these are various relevant applications. In this, there are only two basic mechanical processes or basic fundamental mechanical activities involved. One is advanced robotics and the other is 3D printing. So these are different technological pillars. Now, how do they become part of Industry 4.0, or why are they part of Industry 4.0? If you can see, there are three basic things which are helping for digital transformation of manufacturing, wherein what you do is you are integrating the separate systems and processes initially, and you try to integrate them through different computer systems across the entire setup. So there you use Internet of Things, there you use cloud computing, and there you use big data. Now these three are the heart of digital transformation. Okay, when a digital transformation takes place, successful, if industries are using it, they become digital with their existing physical systems and products, and the interfaces that come up, they become faster and become more productive. So there the system can work hand to hand with the suppliers as well as with the customers for the real-time change into it. Now, how does that work? The first and foremost thing is the Internet of Things. Internet of Things, if you refer, it's nothing but a network of physical systems, physical devices that are interconnected digitally. Okay, so somewhere if you see that there is a transportation or the material handling system, you have certain machineries, you have the people working in the system. It's not that somebody is cycling over here. It means to show that somebody is moving across the entire system. There are mechanical devices, and then you can what you see is it's not merely to an industry. It can be smart cities, it can be energy sector, it can be sensor based things, and it can be any of those things which are connected together. So IoT helps to facilitate the communication and exchange of information, exchange of data through internet. So maybe it can be through smartphones or it can be household appliances. Today you see cars cars are also smart cars, and now buildings are also becoming smart buildings. So everywhere you can see that things are when you just enter into lift and you press on your floor number. So suppose if your floor number is 4 and you stay on the 4th floor, maybe the doors get opened, the AC gets started on the 4th floor. So this is how smartly things are working. So you use different sensors into it. You use different RFID tags, the softwares and electronics, and that get integrated. You see the simplest form is that you have those uh, remote controlled AC and remote controlled fans, and then the switches. You can switch on the tube lights instead of going to a particular position. You can do it through the remotes, and now these remotes are coming in your mobile as an app. So instructions can be passed on through any of such devices. But we know those devices. We use those devices, know those devices. But what happens in between them is something which is related to transfer of data through the internet. And with the advancement of say 4G technology and 5G technology coming up very soon, this would become faster than what we see today. Now, when this information is being passed, you generate large amount of information, large amount of data. So that data is termed as big data. Okay. So big data, you can see over here, this is being worked upon as a big data example. A big data refers to a very large and complex set of data that is generated by our IoT devices, say our remote, say our smart car, say our apps, say our the gadgets that we use. So what they do is they generate some information. I say yes or no. If I say switch on the TV, switch on the AC, switch on the fan, open the locks of the door. So data is generated. Some instructions are generated. So this data cannot remain in your mobile. This data cannot remain on your doorsteps. So that comes that gets transferred, that gets stored through a large set of say cloud servers, through different websites, through different computer servers or sensors. They come from cameras, they come from your mobiles, they come from different apps, and all such data are in different formats. They use different protocols. So if you use this for any manufacturing industry, there are, because of such different types of data to be considered, and the information that comes from the production equipments, say like a CNC machine, like a 3D printer, or say a robotic device or a material handling device, they have their own sensors and databases, and they are collected together, they are clubbed together through the ERP systems. So this data is constantly getting generated at a very high speed, and in very large volumes. So such data which constantly gets generated in very large quantity, in very high volumes, it's almost impossible to handle individually or say manually by a person or by a group of people. So there you need a hardware infrastructure where you can store as well as manage such data. So that system which stores and which manages this data is the cloud computing. So through cloud computing, you are always in constant connection with the physical system. Data is generated, it is stored on this cloud computing, wherein you have a platform to store and process any sort of data that you generate at remote servers. You don't need to create a physical server at your place. It is somewhere remote. You just pay for the space that you occupy on the server, and that is being stored. And then the best advantage is that you can use this data, you can use these decisions, you can use this information from anywhere that you want. So now when you have such data, cyber security comes into picture. So how to save your data? Say I have my internet banking facility. I have my internet credit card facility. I have an Aadhaar card number that is connected with many of the things. Now that data has to be saved. That data has to be protected. So such cloud computing and big data analytics through Internet of Things requires cyber security also. So a new branch, a new pillar is that way generated. However, we would not focus more on the cyber security part, because for 3D printing part, we need to understand these three basic pillars: the Internet of Things, cloud computing, and big data. Now, another aspect prior to 3D printing, we have observed robots since last 50, 70 years. Since the early 1950s, robots have started coming in. Today, you can see that they do a lot of things. So there can be individual robots which work on a single part, okay, or there can be an individual robot in a large system, but it keeps on doing an individual work. Say, for example, in this particular case, you can see that there is a single robot which is doing the task of you can see that it is doing the task of packaging. But here there is a robot which is doing only one task at a time. But then there can be robots which work on a single product. Multiple robots work on a single product. So they have to work in constant connection with each other, in the right rhythm they have to work upon. And they work at a local place, but they can be connected together through an external source now. So right from this position 1, we are moving to fully automation robotics. Now these robots are becoming a part of the 3D printing system. You call such robots as collaborative robots. So nowadays they are known as cobots. So they are collaborative robots. They work together with each other. They are designed in such a way that they work safely around some group of people also. So that's how they can relieve you from your task or from, say, certain repetitive or certain dangerous tasks which they might perform. And then the best thing is they do not take tea breaks. So that is how this system is evolving as a part of Industry 4.0. And the most important aspect which we wish to discuss is the 3D printing as a pillar in Industry 4.0. There are different aspects and different fields where you see 3D printing taking its own role and creating its own space, say being it electronics, be it functional parts, be it food industry, be it biomedical applications, be it space, aerospace, be it defense, anything that you can think of, 3D printing is taking this by storm. And what must be the reason that as a technological pillar, 3D printing is involved into Industry 4.0, and we do not involve the other manufacturing processes, the conventional processes like, say, machining or, say, forming or, say, casting? There are certain reasons behind that. See, we know that 3D printing is able to produce parts in such a way that that new system is evolving, wherein it is possible to go for intelligent product system. You can converge automatic and autonomous machines together and try to make them intelligent systems who are able to exchange the information from the software or from the servers and respond them quickly, so that the entire management of the production activity can be very well taken care of. This is faster and prompt than the other manufacturing systems as on date. 3D printing, in a way, it is capable of turning our usual 3D drawings, 3D design into a product without any major intervention. So if you want to convert a 3D drawing into a part, say you want to use Mastercam to devise a system, then you will need to generate, you will have to work on that software and generate a G-code program. That program has to be fed to the machine, and accordingly milling or turning process would be carried out. You are required. But 3D printer, you only need to have a 3D design. Even you don't need to have a design. If you have good quality of scanners with you, I can just stand at a defined position and it would scan me and convert that data into STL file, and then it will do all the jugglery and eventually print my own bust. So the thing is, this is the only process which can work without human intervention from zero to ultimate. So then the thing is, what happens is we don't need expensive tools and fixtures. Our requirement of tools and fixtures is drastically eliminated by this. And when that happens, we don't need to go for post-processing also. We reduce the wastage of material, and finally, we reduce the human intervention. So in a way, we are moving towards a futuristic industry where you don't need to worry, your inspection requirements are reduced, your quality check is reduced, wastage of material is reduced, and everywhere in all these things where human is a prerequisite, you can reduce that. So 3D printing leads towards a manufacturing system wherein you can have a factory of future where there is no human intervention. Thanks to 3D printing, factories have the ability to increase their flexibility. Today's factory can become more autonomous. It can adapt to the requirements of certain, say, demands in the market. So suppose if I feel that we have designed and we are producing, say, 3 different shapes of a chocolate, but eventually we find that right now a smaller version of the chocolate is more in demand. You can immediately change the production scenario. The way in which you can do it with the conventional process might be different. You will have to make drastic changes into system if you want to change this. But in 3D printing, only thing is you need to just change the execution of the drawing. Rest everything will immediately change by itself. The other advantage is 3D printing is able to enable us to manufacture any sort of personalized object. Okay, you don't, if somebody says that, okay, I don't want this particular shape, I want it to be slightly bulged, I want it to be slightly larger, I want it to be slightly smaller, then you don't need to have any new mold, you don't need to go for new pattern. So those time and cost associated with it are totally eliminated. You don't need special cutting tools for it. You don't need special dies for it. So those things are a limitation for, say, machining, where you need different tools, for forming, where you need to change the dies, for casting, where you need to change the molds. All those requirements, the time and the cost associated, are totally removed when you want to go for personalized or customized design. And most importantly, the final thing which is enabling 3D printing is it is a sustainable process. 3D printing is a very big ally of environment. It is supporting, it is complementing the current climatic situation, and helping to devise a better sustainability in the manufacturing processes, because it consumes lesser resources. You don't need tools, you don't need dyes, you don't need molds. So the cost, time, and material associated with it is removed. And in the meantime, any of the process you carry out, you increase the carbon footprint. So that way it is helping to reduce it. And finally, it is generating very less wastage. Waste management is a very big issue today. To take care of such wastage material and to to eliminate it, to recycle it, to reuse it is a very big issue. But 3D printing in a way is generating very less wastage. And whatever waste it generates, it is nothing but the parent material. You can rework on it, you may reuse it. You may not use it to produce the functional parts, but at least for prototyping you can use it, because prototyping is only to give idea and to give you a feel, to give an appearance. You don't use it for functional parts. So there are ways in which the very small quantity of wastage that is produced by 3D printing, that also can be reused. So considering this utilizing of 3D drawing into a product, no tools are requirement, no post-processing or human intervention, better flexibility, and customized and personalized object to be manufactured, and sustainability. These are different things which are enabling 3D printing to become a part of these factories of future. And rather, when we coin the word factories of future, but these factories are becoming factories of present day. That is very fast happening in Western countries. It may take some time in India, but in a way, as an individual process, 3D printing has taken the manufacturing sector in India also to a very huge extent, and people have started moving towards. They don't totally remove their existing setups. Industry 3.0 is not fully removed, but they are trying to integrate Industry 3.0 with Industry 4.0 by using 3D printing as a manufacturing tool and adding these digital platforms to the best of their capabilities. So when you see this generic process of 3D printing, this is well known. Nowhere you see that you need a physical entity, physical tool, or physical mold, or physical parts to be involved, and human intervention is required. I'll take this with a simple example. You have certain 3D source. You have either you have already designed a part with some 3D software, or you have images of objects, say 4, 5, 7, 10, 15 photographs from different angles, and using a software you combine them and create a 3D drawing, a CAD drawing. Or you have a physical entity, say for example my own self. You scan the 3D part, the human or the product, and that scanning data is suitably converted into CAD. So CAD is what you need initially, and everything that you do to generate CAD is digital. You need software, you use software, you store data, you store cloud data, you store point data, everything is stored, and that becomes a CAD drawing. This CAD drawing is converted into tessellation is carried out, and an STL conversion takes place. So what you do is you divide this entire drawing into layers. So now layers become 2D drawings, and for those 2D drawings, you can very easily create a G program. So programming is carried out. So this part geometry, this CAD geometry is converted into STL, and each layer in this STL is converted into a program. And with the help of this program, you try to convert it into a part geometry. In the meantime, you will need to set up machine and process parameters. In the meantime, you also need to define certain auxiliary geometries like support structures, etc. The inclination of how you want to print, what inclination you want to print. So those things, today the softwares have become smarter, so they suggest you the best way to align the part where you can save time or where you can save material, or you can have a better trade-off between the time and the quantity of material that is being used. And so with that, you create an object. So till the part is formed, or the way in which the part is formed, everything is digital. There is no requirement of you to do something. So that drawing can come somewhere I can sit in Surat and can create all this and can give that data to a 3D printer in Delhi College, and the part can be printed. Once the part is printed, now human intervention comes, or you can use smart robots to pack it and to transport it. So this is what is possible. At an individual level, if you have this with you, you are able to print anything. Say, for example, a switch, an electric switch breaks. So what we do is we call someone and we ask him to replace it. Or say a foot of a chair is slightly broken. You need to replace that foot of that dining chair. Or say, for example, a portion of a wooden bench or say a wooden cupboard is broken. So either you need to ask someone to a carpenter to make a similar type of piece and fit it over there. But in case if you have a 3D printer with you, you can just measure the requirements, you can fix up the dimensions, and you can print anything so as that it would fit at the right position. So this is how this becomes a very successful process in the time to come. This is the same example which I want to show how data path is transferred. At our place, we have a statue of Sardar Vallabhbhai Patel at our institute main gate, and that can be scanned and converted into a 3D CAD data, and that 3D CAD data is converted into STL file. Certain auxiliary parameters are fixed for support structure, machining parameters are fixed, real 3D printing is taking place. You can see these are support structures, so these are auxiliary drawings. So those support structures are removed, and you do certain finishing and coloring of the parts, so certain post-processing activities are carried out. All of these things are digitally done. To some extent, you need human intervention in post-processing, but till the part that is printed, you don't need any human intervention. As a part of 3D printing, as a part of Industry 4.0, there are many things which are required. So even though you can control it from a remote place, whatever be the remote place, you will have to sit on a computer. You will have to work on a computer. So what things are required? You need to work on the CAD model, number one. So there is a scope of working on design software, and there is a scope of converting the CAD, converting the 2D images or a physical part, scanned photographs into CAD. So you need to you have a scope of working on design software and translating software. When you want to make this part, so you will have to build it. So you will have to work on the process and the part dimensions also. That is also something that you need. But once this CAD drawing is ready, once your building requirements are fixed, you need to go for the processing part also. You will have to verify the CAD file, convert it into suitable STL file, convert it into a suitable program similar to our usual G code programs. You will need to define the orientation of the part. You will need to define the parameters of the process. So all those things you can work on. Now with the advancement of technology, with the advancement, better capability machines are being built. So say before 5 years, the best layer thickness, the smallest layer thickness that you could achieve on an FDM 3D printer was 300 microns, 0.3 mm. Today you have FDM printers which can go up to 0.07, 70 micron size, 0.07 mm size. So parametric capabilities are improving. So if you can improve the parametric capabilities, you can vary the orientation requirements. And that is how there is a tremendous scope of developing better software which can work on better parameters. Another aspect of this 3D printing is the materials. You need to work on materials. You can study the chemical properties, you can study the physical properties. Say for example, when I use say PLA or say ABS, both these materials are widely available and used materials. But in either of the case, their capability to work after say 3 days or 3 weeks or 3 months or 3 years is different. So if you want to achieve the good characteristics of different materials, you will need to create newer polymers, newer metals, newer alloys, specifically for 3D printing. So there is a huge scope of studying the physical properties and chemical properties. So even though remaining into Industry 4.0 as a core manufacturing engineer, there is a vast scope of working and contributing in strengthening this pillar in Industry 4.0. And most important thing at the end, which appears to a customer, is the part at the end of post-processing. So there is a scope to work on post-processing also, where you can improve the quality and you can improve the size, or you can improve the aesthetics, you can improve the appearance, you can improve the shine, you can improve the allowances and tolerances of the dimensions, you can improve the assembly of these parts. All these things, they can be worked upon through various post-processing. Post-processing on metals using say forming or machining process is quite clumsy and complex, whereas in this case it becomes an easy part. You can work on your own desk and you can carry out these activities. So these are different aspects to make a part. As a manufacturer engineer, you can work on any of these aspects for any process, for any sort of combination of raw materials, so that 3D printing as a pillar of Industry 4.0 becomes stronger than what it is today. What are the various advantages which can be achieved if 3D printing is part of Industry 4.0? As we discussed, we are free from the complexity of design. We are free to tailor the microstructure. So generally what we feel is that temperature has its own effect on a part that is machined or that is bent. And so you need to go for heat treatment. Whereas in this case, you can very well define the type of microstructure that you want and you can produce it. If you wish to make it lesser dense, you can increase the porosity. If you want to make it porous, you can reduce this density. If you want to make it a solid part, you can make 100% density also. Apart from that, you can change the design, the structure, say at 50% density, internal shapes, internal design, that also can be worked upon. So you can tailor anything that you want. You are free from scale. So if you make a part which is say in the size of 1 by 1 centimeter, you can also make a part that is of the size of 1 by 1 meter. So the same design, the same aspects, the same drawing, the same STL file can be scaled up into dimensions. Of course, the capability of the machine plays certain restrictions into the scaling part, but yes, it is possible to scale up. You are free from batch sizes. Usually in mass production, you have to say that 10 parts would be produced, 15 parts would be produced in a single batch. Here you are free. If you want to print 10 parts, you can. If you want to print a single part, you can. In processes like SLA, in processes like SLM, in processes like SLS, which uses powder-based technology or uses resin-based technology, you make one part or you make 10 parts, same time is taken, because the laser source travels or the UV source travels across the entire bed in a defined amount of time. During that time, you cure one part or you cure 10 parts, it does not matter. So in FDM is an exception. In FDM, because you are depositing material through the nozzle, so if you print one part or you print two parts, time that would be taken would be doubled in that case. But apart from FDM, for all the other processes, it is possible to make the entire process free from a specific batch size. We are free from wastage of energy. We don't waste energy. We don't waste raw material. So that is also an advantage. You don't need to assemble also. You can design the part instead of making parts separately, 3 or parts separately, and then assembling them, you can design it in such a way that altogether all those 4 parts are printed together in the assembly itself. If they are to move, if they are to slide, if they are to glide, if they are to rotate with each other, they can very well do it. So that's how you are free from creating assembly. Now, if you are free from assembly, you may not need riveting, you may not need nuts and bolts. So that way, the strength of the part can also be increased. And you are free from variability that comes because of breakdowns and maintenance. So suppose on a CNC machine, if I am working and I am less efficient than somebody else, and during my batch it works, the machine works well, and when the next batch comes and you have an efficient operator, but the machine fails, so that time is wasted and he is not able to produce. What I produce and what the other guy produce, its quality is different and there is scope of variability into it. Whereas if you are printing, you don't do anything, entire thing is done by the machine. So there are very less chance of finding variability into the parts that may be printed during breakdowns or maybe during these changes in the shift or say during maintenance period. So those things are largely eliminated. But then what are the challenges which 3D printing faces to become an integral part of the Industry 4.0? The most important challenge is the high cost of the machines. Not only machines, but the materials. Apart from FDM and to some extent the SLA machine, all the other processes, all the other machines, be it say SLM, be it SLS, be it polyjet, whatever be the type of system, be it for polymer material or be it for metallic material, these machines are very costly. Your initial setup cost, your operation cost are very high. With the advancement, maybe with more competitions, these prices would reduce. But as on date, high cost is a very big challenge. There is a need for more rapid 3D printing throughput. Okay, so the technology has to be enabled in such a way that the operating speed is increased, the resolutions are improved, accuracy is improved. There is a requirement of building larger volumes. Most of the machines have the size of say 250 by 250 by 250 mm. There are few machines which may be say 500 by 500, but then cost would be 3 times than what you have. So just by increasing the size up to half a meter, the cost drastically increases. So there is a huge requirement of transformation of the technology and the cost associated with it. If that is done, probably this can faster replace the conventional processes. Very big problem is that you do not have specific ASME standards, ASTM standards for 3D printed parts. Say for example, when you are printing, you are trying to hybridize and print a composite material with the help of 3D printing. You do not have the standard dimensions for that part to be tensile specimen to be printed. So what you do is you either use certain composite standards or you use certain standards for specific polymers with certain nano powders. So those things are being used. So there is a lack of consistency in the assurance of quality practices. So more standardization is required, more drafting of rules are required, more standardization of designs is required. So those things are something which, yes, people are working on it. There are many people who work on it, but still we do not have the standards for it. So that is something that is lagging. The design software that we use, they are also not adequately exploiting the full potential of 3D printing. So today ANSYS has a module which is meant for 3D printing. Abaqus has a module which is meant for 3D printing. But full-fledged 3D printing design softwares, analysis softwares are still not available. You use your conventional wisdom to utilize the existing software capabilities for 3D printing activity. But still, you have very less. Yes, drafting softwares, CAD softwares have improved a lot for 3D printing, but analysis softwares still would require some time. I don't say that it would be decades, but maybe a few years to gear that part up. And most important thing, where this program comes into picture, a general scarcity of suitably trained personnel who can collaborate for ideas, and not only ideas, who can collaborate for the other pillars of Industry 4.0. So as teachers, we have a very big role here. Create engineers, create entrepreneurs who are ready to collaborate between ideas and between systems. And we also need to create trained manpower at ITI and diploma level who can work on the physical systems. In Industry 4.0, we generate cyber physical systems, but there is a component of physical systems. To work on them, we need better ITI and diploma students. And for them, rather than traditional trades like, say, electrical or like machining or like turning or other things, we need dedicated syllabus for creating operators for 3D printing process. So these are different challenges which all, including us, have to work on. So these are certain key issues related to that. So more or less, this is the revision of what I discussed. So I would like to conclude with these certain remarks. Most manufacturing industries will benefit if they adopt 3D printing technology. How they would benefit? Because it would result into significant cost saving by properly digitizing their process and the inventory. As the speed, reliability, safety, and quality of 3D printers will improve, which is going on, and it is expected that within next 5 years, we will have half the price of what is it today. Then 3D printing would set to play a very major role in the digital transformation of industry. Now, as this 3D printing technology evolves, develops, a range of new products can also be manufactured. More complex designs can be taken care of. More complex functional parts can be made. So those things will definitely come up. So now when you are to design new parts, you need more design engineers, you need more data enablers, you need more people to work on those data sets. So things would result into a spiraling rise in the requirement of trained manpower. Now, rate of development of specialized printing materials and integration of digital security to protect intellectual properties and the certification of the parts that you make. Even on a smallest gold jewelry today, you have a hallmark. But on 3D printed part, we do not have any certification yet. Okay. On a part that you have, you will see ISI mark or BIS mark or certain agro marks, depending on whatever product it has. But 3D printed products, they do not have any certification. So when you will have such certifications available, when you will have proper security of your CAD drawings to protect your intellectual property, then naturally the absorption of 3D printing process in Industry 4.0 would that adoption would be boosted like anything. These are some of the 3D printing facilities that we have at our lab. We work on FDM printer, we work on SLA, we fabricate carbon fiber and glass fiber based products. We make our own filaments for FDM process. We are blending different polymers to create new hybrid polymers. We also work on nanocomposites. So these are different things where we work on, and I'm sure that you or your students would join us. I request you to go through our regular updates on YouTube channel or on our Facebook page, which is Manufacturing Research and Innovations Group at SVNIT. You will find us on different social media also. And someday when we are totally out of this COVID-19 situation, I request you to join us someday for a personal visit, or maybe for some conference, or maybe for some programs at our laboratory on our campus. So with this, I wish to wind up my discussion. Thank you very much.
Thank you very much, sir. Thank you so much. The area and the challenges, the advantages, the application of 3D printing that is covered by you and presented in such a manner that by knowing that it is the only process by which you can reduce time to market by reducing the modeling time and other sort of such critical things. Even though there are some IoT devices which are available to for mounting on other manufacturing processes, but considering the advantages of this 3D printing, we can see the future that, as you say, that if one person is here and is coming with a demand that I want a copy of this component, it will be possible. So 3D printing is a key that a key component or a key element of the revolutions in industries which are taking place. Thank you very much, sir, for giving such a wonderful information.
It's my pleasure.
Sir, our pleasure also that to have you with us in spite of you are having some throat infection, but you presented in a very beautiful manner that no thing was there that it was missed. Now I request Dr. Chirag Maradia, sir.
In case if there are any questions in between.
I'm sorry. If any participants are having any query, they may ask or they may put in chat box so that we can solve this. May I request participants, if you have any query, you can ask Dr. Harshit Dave, or you can put in chat box. On behalf of you, I can read it. Or if now you are not having query and you want to refer the slides again, and meanwhile you are having any query, so you can definitely mail us. We'll be
Yes,
reverting back to you. Yeah.
And I would always appreciate if there are any interaction after the session.
Yes.
And after the program. These programs are meant for creating better synergy and better networking between teachers and between research scholars. So I believe that in case if you have any question, maybe in coming days or any time in near future, you can always approach the coordinator or maybe directly to the speakers. So I will appreciate then also.
Sir, may I
And
request you?
Yes, one more thing is we have our that we are organizing a general program, Advances in Manufacturing, as a short-term program. So again under Atal program, we have it in the end of last week of July, probably 26th to 30th of July. So I believe if somebody wants to take an advantage, the speakers that we have lined up are from few IITs and few industries as well as NITs. So yes, I would like to request one and all to go through the Atal portal. I don't know how you can apply. I'm not sure about it, but through Atal portal probably you can put your online applications in case if you haven't attended a similar program in past.
Yes, sir. It will be helpful if they are interested in manufacturing and the associated processes and management processes. Sir, we will be needing the presentation slides that you have shared today.
Yes, I will mail it to you.
Yes, yes.
I think the size is too large, so I will slightly reduce the size and then I'll send it to you.
Sure. Sure, sir.
Fine.
May I request Dr. Chirag Maradia to present a vote of thanks on behalf of all of us to Dr. Dave sir. Chirag sir, please. Chirag sir is
Okay.
working here
Am
in
I audible?
Yes, you
Yes.
are audible, sir.
Okay. Thank you, ma'am, for giving such opportunity to me. Respected HK Dave sir, organizing team, and all participants. I am Chirag Maradia from LE College, Morbi. On behalf of all participants, I would like to say that we are very thankful to you, sir, for this knowledge improving session. Many informations provided us during this session, like what is 3D printing, difference between additive and subtractive manufacturing, how 3D printing system works, why 3D printing is important in current scenario, and what are the advantages of this system. Application of 3D printing in key areas like medical implants, space industries, disaster management sector, etc. And in Industry 4.0 era, how machines works in integration with IoT, cloud computing, big data, data analytic, etc. So this topics improve our knowledge of 3D printing and its application during Industry 4.0 era. I am again say thank you to Dr. H.K. Dave sir for conducting this informative session on 3D printing, which is one of the most important field of current manufacturing industry. Thank you very much, sir.
It's my pleasure. Thank you. Thank you very much.
Thank you, Chirag sir. Thank you, Dave sir.
Okay. Okay. Thank you.
Yes,
Thank
sir.
you very much.
Yes, sir. Yeah.
See you soon. Bye.
Bye, sir. Bye. Participants, you may also leave the meeting, and we'll have next session at 1 p.m. We'll be sharing a link to you. So have a good time till then.